Hey, I'm John Anderson, graduating soon from the Applied Data Science Master's Program at Syracuse online. I really enjoyed it, learned a lot, thought it was very applied. I like that part of it, right? I feel like I actually learned skills that I can take on and try to use in the real world and in a real new career instead of just more of the theory, although that there was some of that in there too. So, um, all positives for me. I'm going to be taking you through some of the projects I've done and mentioning how they relate to the goals we were given, and we'll go through that. One thing you will notice, I'm a big sports guy. The reason I'm in this program at all was because I initially got very into data and data analysis and insights and prediction from baseball statistics. So you'll see that through some of these projects. Sports data, just to me, very just very plentiful, very understandable, and very relatable and usable for the kind of things we learn. And it is a little bit cheating because in real world data, company data, it's not as structured and not as easy, and there's a lot of other factors. When in baseball, more than anything, everything can be quantified. The numbers are all there. You can get anything you want. So it did make things a little easier, which was an added bonus. But so that's my main hobby and my main interest. So that's what you'll see as we go through this. So yeah, we'll get into it. For goal one, I don't know if this was really supposed to be in this video because it's not. I'm not showing you anything, but I figured, and I wrote at length some of my thoughts in answering that question, and I kind of went a little overboard, as you'll see. But I did want to just comment on that briefly. The broad overview of major practice areas in data science, that was the question. And I have had this thought process. I mean, I was born in 1990, so maybe on the younger side, although I'm 29. I guess I'm not too young anymore, but I still feel like I'm brand new to everything. I was probably the last generation that got to go through this. Like, I remember a little bit, at least, what it was like with no internet. I was 13 when we finally got high-speed internet, so you remember pretty well from 1 year 3 to 12. Those years are pretty clear. So then I kind of went through, and now, I mean, from the last 20 years of my keeping memories, it's just been really insane how much it has changed everything. And I'm sure every generation in like human history has said this, like, wow, life was so much different 50 years ago. When they invented the wheel or whatever, whatever it may be, it always seems like a very generational, just like revolutionary change. So maybe that'll just prove to be, maybe people in 100 years will be thinking this internet change wasn't that big of a deal, but it sure seems like it is now. And I'm sure it really seems like it will go down as, excuse me, one of the bigger, just one invention that really changed the world, the microprocessor and the internet, and how fast everything has become. Because, I mean, the world has shrunk quite a bit. And data science, pretty new. In terms of how it is today, it's very new. I know some of the math and theory has been around for close to 150 to 100 years, but pretty new. And businesses, I think what we're seeing right now is that businesses are really getting into it in the last 5 to 10 years. I think most companies of certain scale have dedicated a lot of money and resources into data science because they are realizing how important it is. So the main thing for me is just that idea that we have all this information out there. We can describe everything with a number, and it's how computers are, ones and zeros, right? But our brains just aren't able to look at thousands and thousands of rows of data and like make anything out of it, at least not in any amount of time that is feasible, right? So these data science concepts and the coding, especially, I'm talking more about the actual applications, really make a huge difference, and that is really just making us learn so much more. I mean, we've been learning more and more about the world and ourselves as we've been on the planet, but I think that has really that curve has really started accelerating as we've been able to process all this data. Because 50 years ago, 100 years ago, there was just so much stuff we couldn't learn. The information was out there, but we couldn't do anything with it because we didn't have the processing and computing power. So that's really data science to me, is using computers to do what our brains can't with large amounts of data by doing those incredibly fast computations. And obviously it was up to us to do the math and figure out how to design this all. But that's data science for me, and you can read more of that detailed in a little better wording in my first goal paper there. But it's exciting for me. I really like the field of data science. That's why I signed up for this, and I'm looking to transition into that career as quickly as possible. So it's been fun to learn. Now we'll go on to goal number 2 here and show you some actual code and an actual tangible thing I did. Okay, make sure we're going here. Pardon me. All right, we're on to goal number 2, which is collect and organize data. Now this is going to be a little rough of a video because it's very spaced out, and I can't actually run the scripts, but you'll see why. So this is something I made over the last year, learning more Python with this program. It's a bunch of scripts that go out and get all the Major League Baseball data for each day. There's games every day in baseball, as you may know, and it's cool if you're playing fantasy, which is what this is for. So fantasy baseball is you pick players and you get points and stats based on what they do in real life. So the purpose of this is to collect all the statistics for all the players that you might want to pick for that day, or that you might already have, depending on the game type you're playing. But the details aren't as important in terms of how the game works. But we'll go through each script, and I'll just describe it, and then I'll show you an example of the final output. But again, since I'm recording this in January, there's no baseball going on, so these scripts aren't where they reach out to get the information. That's not going to work until the websites it's grabbing from are updating again. So script number 1 is get mlbdata.py. So this just brings in all the statistics up to that point. So whenever you run it, it's going to get the season statistics up to that day. And here it is. Again, we're not going to spend a ton of time. But basically, it uses Python web scraping with Beautiful Soup. Here's a URL. So fangraphs.com and baseballsavant.com are the 2 websites it gets statistics from. Those 2 websites have pretty much every stat that I could, not all that I could think of, but all the ones I cared about. So it basically finds this table, and this is a very specific table, and this URL is very long because it is looking for, it gives the current season and all these parameters you can set to slice it, but that's set to exactly what I want. So it goes to that site and grabs the table. Has to change some names to match the other site, and that's a problem when you're bringing stats from 2 different sites. Some websites name players differently, so you see a Nick and a Nicholas, a Dan and a Daniel, stuff like that, and that handles that. This function is the same, it's just for a different set of statistics. So the standard statistics for the first one, and that's just like these, at-bats, hits, singles, etc., the basic stuff that you'd see in a box score, and this has more advanced statistics. And then we also do split statistics in here, which a split means I want to know how a guy does against right-handed pitchers and against left-handed pitchers, because there is a difference in baseball. Typically lefties hit right-handed pitchers better and vice versa. Don't need to go into that, but it's true. So it grabs all of these stats for every split. So I want to know what a guy's batting average is total, and then against righties and lefties, and I do that for every stat I want. Again, not going to bore you with all the fine details of this, but after it collects everything, it uses these functions to merge them and just kind of make things a little cleaner and more useful, because you can imagine it's bringing in a lot of numbers and we need it in a specific format. So a lot of code, kind of ugly. Here's all these URLs to use. So this is the Baseball Savant website, which is a little more difficult to scrape from because it's not just standard tables. So we had to do a lot more URLs and custom stuff like that. And you can see we're approaching 600 lines of code here to go get all this. After it gets it all, it merges it and puts it in a file. It does another thing to look at a team complete lineup. So a lineup has 9 players in it, and if I'm looking at pitchers and I want to say what pitcher has the best matchup today, I want to look at how their opposing lineup shapes up. So I want to add all the players that are projected to be in the lineup, all their stats up, and get like one metric to give that lineup a certain rating. That's what that does. Prints them all out and cleans it up and gets that out there. So that's the big one. The second one is the daily stuff. So every day the pitchers are different, the lineups are different, the matchups are different just in terms of what team is playing what. Rosters change, players get demoted and promoted, and there's another part of fantasy is the daily fantasy sports websites. They give salaries, so when you're playing this game, you have a certain amount of money to spend on a lineup. So you have to get the salaries for each player. Every player is priced differently, with the better players being more expensive, obviously. So you need to get that information every day because that changes. So that script goes and gets everything we need when on a day-by-day basis. This function gets those salaries from the websites. This function gets, it usually uses what's collected in the first function to just get what teams are playing what. This function gets probable pitchers for that day, so who's starting, what pitchers are starting. This goes out and gets the lineups from this baseballpress.com website. And if there isn't a lineup yet, lineups usually come out 3 hours before each game. So if I'm doing this in the morning, I'm not going to know the lineup. But there's another function in here, which is this one. This website just actually projects them if they're not out yet. So it just takes its best guess, so we can use those. This function gets the current rosters, so we know what player is on what team and who might be playing, who can actually play. Because if a guy gets into the minor leagues, we don't really care about him for that day. And this calls all the functions, and that takes care of it. So basically all these are just saving things off in their own functions. We're not doing anything. We're just running the functions to save stuff, and then we grab it later. Number 2, script number 3. This is 3 and 4, 5 and 6. Maybe we don't even have to go through those as much. I'll click through them, but basically they use the lineups and the stats that we just collected. And go through and just put all this together. So if the Pittsburgh Pirates lineup is there, it goes through and says, okay, who's in the lineup? Let's get their stats. Let's get their stats against right-handed pitchers if they're facing a right-handed pitcher that day, or a left-handed pitcher if they're facing a left-handed pitcher, and just puts it all in a sheet. Does the same with pitchers. It goes and gets the pitcher's stats as well as every hitter they're going to be facing. And this is that lineup breakdown we talked about a little bit. It adds up all the players in the lineup stats to get a lineup metric to show. This lineup averages a 260 batting average with a 410 slugging percentage, stuff like that. So just make it a little more clear what a lineup looks like instead of each individual player. And then last is just creating the master sheet. So it just takes everything we did, puts it all together, and puts it in a sheet that we can use, renames some columns, gets rid of some things, cleans it all up, converts to some numbers and sorts and things like that. Yeah, I don't think anybody actually wants to go through and look at all this code. I'm sure you guys have much better uses of your time, but it is here and it does work during the season. You can also email it. I use this, just email it to myself. Every day I actually run this stuff from a website called pythonanywhere.com that you can schedule scripts to be run. So I pay a little bit a month for that and just have this stuff shipped to me automatically so I don't have to do anything each day. So pretty cool little project. Helpful if I'm playing fantasy baseball. I'm not a professional by any means, or I'm not like putting a ton of money into it or anything, but it was a cool way to strengthen my Python skills and see what was possible and take it there. Here's the final product. This was for August 2nd of last year. So you see, we'll just go by one team. We'll see the Arizona Diamondbacks. That's not a good example, I guess. So this is the Rockies lineup for that day. This is their salaries. You can see they're playing the Giants. The betting line gave them 7.2 runs implied, so that means they're expected to score about 7 runs that day, which is a ton. Here's their each stat. So Charlie Blackmon against left-handed pitchers hit for a 4.03 weighted on-base average that year, up to that point at least. Here's the pitcher's statistics. You can see this pitcher actually not very good, which is the reason why that run total is so high. This 386 expected weighted on-base average is very bad. Gives a 1.6 home runs per 9 innings pitched, very bad as well. So you can just kind of see how this gives you a large picture of the day's games. You can see a ton of hitters in here, almost 200 for that day. A lot of information and all pretty clean. I used an Excel macro to just put this conditional formatting and clean stuff up. So after my scripts run, which are just scheduled, they just run. It gives me the file. I run in here. I run a macro, and it cleans it up, and I'm ready to go. So that is goal number 2, collect and organize data. I think that pretty much showed my strength in doing that with Python. Live data changing every day, and it is able in just a couple clicks to go get a ton of information and organize it and make it look good and useful. Thanks. Okay, goal number 4 is develop alternative strategies based on data analysis. We're going back to baseball. For this one, there are at least one thing in here that's not sports related, if you're sick of hearing me talk about sports already. But here we are, so let's go ahead and show you this. So I use clustering analysis in R using k-means clustering for this. The idea was that in baseball, there's a lot of data, and you want to make decisions. Maybe a manager wants to decide who should be in the lineup that day based on what pitcher they're facing. And if you have a hitter that has hit a pitcher very well but only has maybe 10 at-bats against him, that typically doesn't mean anything. You need a lot of data to really say, like, this means something. This guy has... Yeah, I mean, you could be 2 for 2 against a guy with a home run. That doesn't really mean anything about how the third at-bat's going to go. So the idea of this is to cluster pitchers together, and instead of having hundreds of individual pitchers, we can maybe categorize them all into 5 groups. And then you could say, okay, how does all my hitters do against this cluster of pitchers? And that way you can obviously see how you can get way more data there. Much more useful. So for this, we use the Major League Baseball pitch-by-pitch data set. It's pretty incredible that baseball gives these massive data sets out for free with every pitch thrown in all their games. I mean, there's 750-some thousand pitches thrown last year, and every single one of them is in this data file. So that's what we used for this. So quickly, we bring in the data, pick the columns we want. These columns are the name of the pitch, the release speed, so how hard it was thrown, and then this is the horizontal movement and the vertical movement in inches. Just for this example, I've done a lot of stuff with this, but for this example, to make it a little quicker, I just used sliders. So I just wanted to see a slider. So slider is a pitch that is a little bit slower than normal and moves from left to right. Generally, obviously, every pitcher has a different movement on its slider, but you will typically see it move more left to right or right to left, depending on the handedness of the pitcher. So for this, I wanted to go ahead and cluster them all by how their sliders, how fast they are, and how they move. So I got every pitcher. For every pitcher I looked at, every slider they threw, took the average speed, horizontal, and vertical movement, and I made a new data frame with that. So one row would be one pitcher, his average speed of his slider, average horizontal movement of his slider in inches, and average vertical movement. After that, we were pretty much ready to go. That was the heavy lifting, and we just used the k-means clustering algorithm in R. Threw them into 3 clusters first. You can see how that looked. I did a little just testing myself. I knew a couple pitchers that had very similar sliders. They're all left-handed with very sweeping sliders, meaning a lot of horizontal movement. I wanted to make sure they were still in the same cluster, because they should be. If there's only 3 clusters, there's no reason that these guys shouldn't all have been in the same cluster, and they were, so that was a little validation. Went ahead and used 7 clusters to give us a little more, and you can see how that went down. And same test, Matt Boyd slid into a different cluster, but still you can see those 4 still in cluster 5. So I was feeling pretty good about it. Could do a lot more than this, but I'm trying to save some time. I took a lot of time on the first couple of videos here. So real world example would be you take your lineup and look at how they've done, or take your potential guys in your lineup and look at how they've done against pitchers that are in the same cluster as the pitcher they're facing that night, and make your lineup decisions like that. So that was it. That's an example of real world decisions using data and the R K-means clustering algorithm. Thanks. Okay, for this video, I thought this fit into goals 4 and 5, develop alternative strategies based on data and develop a plan of action regarding data. This is an R project that we worked in the Introduction to Data Science class. We used Capital Bike Share data, so that's a bicycle rental company in Washington, D.C., so they rent bikes. You can go pick them up at any station, put a credit card in, and then take it, and depending on how long you have it before you put it back into that station or another station in the city, they'll charge you on that. They have data of every single bike rental. It tells you what bike was rented, what station it left from, what station it ended at, and what station it, or how long it was gone, as well as member information if people were members. I don't want to spend too much time here because my video's already gone long, but here's an R script that I wrote. The main goal of this is to find, if you put in a bike number, you can use this function to get the current station it's at. So it would look up that bike and see the last time it was checked in and give you what station it's at. You can see the history of it. For each bike, you can see the history, and you can see a little bit of that here. So this guy down here rented the bike on January 26th, brought it back the same day, and then it sat idle for 34 days before it was rented again, March 1st. And these are the station numbers it started and ended at, so you can trace the whole path of a bike throughout the data's history, however long you have. Same thing, just how long the station duration here is how long it's sat in that station. But the main win of this, and the main thing that the company could gain and to develop those alternative strategies, would be to circle through every bike that they have and say what we'd be looking for is bikes that have sat at a current station for a long time while that station has been heavily used. So you can see this bike here. Someone took it out on March 24th, and then nobody touched it again until June 16th. And this might mean that maybe the company took it out of circulation for a little bit or something, but it's possible that this bike was broken. And while 18 other people rented bikes from that station, nobody touched this bike in almost 2 months, or more than 2 months. So that signals a problem, right? And you don't want bikes out there that nobody is touching because they're broken, because that's a wasted opportunity, and maybe there's no stations available when someone wants to give you money to rent the bikes. So this script takes a huge data set and makes it very useful in terms of identifying situations where you can make more money by having your bikes look better and be ready to rent at any time. So obviously a lot of things you can do with that. This data was just a massive data set. There's 3 whole years of bike rentals, just millions of bike rentals in that time. Washington, D.C., obviously a very big area. This was a very popular service. So we did a lot of other things with that, but this was an example I wanted to point out for my portfolio. So that's that. Thanks again. Okay, my last project I'm showing here satisfies goal 6, demonstrate communication skills regarding data as well as identifying patterns in data with visualization, statistical analysis, and data mining. This was from the Big Data Analytics class. It was one of my favorite projects we've done, and I think it really demonstrates these 3 things with visualization, analysis, and mining. The project was, we had a base data set about NCAA Division I head football coaches and how what their salaries were. And the project was said, hey, Syracuse, just in a theoretical perspective, Syracuse needs a new coach. How much would we be looking to pay him based on market rate and other factors? This is all done in Python, as you see. This is a Jupyter notebook that makes things very clean and concise and separates the code from the documentation and analysis and things. So pretty cool software here. Jupyter Notebook's very useful. So first you see we bring in the coach's data, and we need more data than just each all the original data had basically was the school and the coach and how much they were paid. So we wanted to bring in some more data to help make this decision of how much to pay. So the one thing the project did ask us specifically was to look at coach salary versus graduation success rate. Turns out, and this became pretty clear to me, that the graduation of the football players isn't going to have much to do with coach salary, and I don't really think it should either, because nobody, frankly, really cares what the players, how they do in school and how they graduate. Obviously, college football is a huge money-making business, and people aren't tuning in to watch the teams because their players get better grades, unfortunately, maybe. So I quickly wrote that off as a relevant factor. So what I did do is I scraped Wikipedia using Python Beautiful Soup. I wanted to get stadium capacities, and I wanted to get the last 10 years records for each school, see how they've performed and how big their stadium is, and as well as recruiting class ranks. So for every year, if Alabama had the number one recruiting class, they would have a 1. If Clemson had the second, they would have a 2, right? So the lower number, the better. I brought in the last 10 years of that and the last 40 years of national championship data. So I did all this with web scraping from external sites. That's all documented in here, but no time to go through all of that. So I have all this data. Here's how some of it compares. So as the stadium capacity goes up, you can see the salary of the coach does as well. It makes sense because those are both related to how much money the school has to pay the coach. Winning percentage, more of the same. You can expect a program with a higher rate of success and more wins to pay their coach a little bit more. Recruiting class rank, you see the opposite relation. As the rank goes down because they're getting better recruits, that would mean it'd be a good thing, a lower number. The coach's salary also goes up. And this one's a little weird, national championships, because there's only one national champion a year. So for the last 40 years, the maximum would be only 40 different schools have them, but obviously there's a lot of 3s, 2s, and there's one school here, Alabama, I think, with 7 national championships. So there's not much of a relationship there just because a lot of the zeros, but it is kind of still, as your national championship count goes up, your coach salary will as well. Here's the correlation matrix of all those. You can see the highest number here, stadium capacity and school pay. That school pay is how much the coach was paid, highly correlated. So we used all of that information to make a regression model to predict what each school would be paying their coach. And here's what it predicted for Syracuse. So it said give them about $2.4 million. Which would be a little bit less, as you can see, a 0.8% pay decrease from what they were paying the year before. So the new coach maybe should come in a little less. Obviously, there's more to consider in this, but it's a good example of bringing in external data, reasoning through how variables relate and what variables should be used to make this decision. And here's some other stuff we were asked, but I think you get the gist. And if you do want, obviously this is all in my final submission, if you want to go through and read all this, but that is the overview. And I think it does do a pretty good job at showing my ability to identify patterns and visualize, analyze, and using data mining to do that. And the communication skills, I think, are showcased just in my ability to write and, organize this. I think I did a decently nice job at writing through and making things clear what we were doing and making it look pretty. So that's that one, and that's my last goal. So thanks for listening. We'll wrap it up here.